For determining the right backup power supply for your electronic devices, selecting the suitable power rating is vitally important. But have you ever wondered why we often see different measurement units, such as watts, VA, and also information about power factor? To start, the power drawn by electrical appliance is expressed in watts, and VA, the volt-ampere. These values define the amount of power that a device needs to run. Both watts and VA serve for different purposes. Watts represents the true power that is taken from the utility grid. It is called active power and it performs useful work. Where VA, the apparent power, represents the power drawn from the wall, but also considering the reactive power. This power is measured in volt-ampere reactive, and it is actually not used in the system. The watts and VA rating of an electrical appliance may not be equal. This may be caused due to various factors, such as different type of loads and conversion efficiency of switching power supply, which is used in almost every electronic device. On the other hand, power factor measures how efficiently the input power is used in an electrical system. Going one step further, in an AC circuit, power factor is the ratio of active power, measured in watts, to apparent power, which is measured as mentioned earlier, in volt-amperes. This ratio varies from 0 to 1. An example of power factor equals 0.7 means that the electrical appliance consumes 70% of active power and the remaining 30% represents the reactive power. In other words, the ratio closer to 1, the better system efficiency of the equipment. Generally speaking, the UPS acts as a bridge in between utility grid and the devices. When the power goes out, it provides backup power for its connected equipment. As explained earlier, because of the type of load and conversion efficiency of the equipment, UPS may be provided with different VA and watts ratings to fulfill those demands. This information can be found, normally in the output section of the UPS specification. These power ratings represent the maximum load that a UPS can support and can't be exceeded. Now, to make sure all concepts are clear, let's use the following example. Given a UPS with output power of 1000 VA and power factor equals 0.7, what would be the output power of the UPS measured in watts? This can be calculated by using the power factor formula. The active power is equal to power factor times apparent power. The result is 700 watts. It means the UPS can support a maximum load of 700 watts and 1000 VA. Finally, as learned in this video, knowing the active and apparent power of your equipment will help you size the UPS correctly. CyberPower offers a complete UPS product line from different power ratings to safeguard your valuable assets.